Welcome to the deep dive. Today, we're tackling a pretty hefty scientific review paper. It sits right at that crossroads, where ecology meets policy and, yeah, even ethics. So this deep dive, it's really about giving you a solid handle on a document that's, well, it's making waves in how we think about conservation and managing things globally. We're looking at impacts of biological invasions, what's what, and the way forward. The lead author is Daniel Simberloff. And this isn't just some list of problem species. It really gets into the growing pains of a whole scientific field, invasion science, which it seems is under a lot of scrutiny right now.
Yeah, that's spot on. And the key thing to grasp right from the start is that biological invasions, they aren't some small niche issue. They're a huge part of global change. Think climate change, habitat loss, invasions are right up there. But the field studying them, it's kind of at a turning point. It pulls from ecology, sure, but also social sciences, resource management. And because it's so multidisciplinary, it faces critique from, well, all sides. We're actually hearing some pretty prominent voices questioning if we even need invasion science at all.
Okay, so that really sets up the core tension for our discussion today, doesn't it? There's a clash between what scientists see is necessary and maybe some public resistance or different viewpoints. Let's maybe start with a history. How did we get here? How did these introduced populations go from being, I guess, assets or curiosities to being seen as ecological burdens?
It's a really interesting shift historically. For centuries, especially with exploration and colonization, bringing in new species was often seen as a good thing, sometimes intentional for resources. You had these acclimatization societies bringing things in just because they were exotic. And the paper points out, Polynesians, for instance, they deliberately introduced rats to islands. Why? As a food source.
Right. And we still see echoes of that today, don't we? Species that aren't native but are kind of appreciated. The paper mentions eucalyptus in California.
Exactly. It's not native, but people value it aesthetically. It's become part of the landscape, almost a cultural icon for some.
So that shows how public perception isn't always driven by the ecological facts.
It's often not. That cultural view presents a real challenge, but the modern scientific reason for concern, that's purely pragmatic. Invasion science really took off, say, mid-1980s, and it was driven by just mounting evidence, overwhelming evidence, really, of threats. Threats to native species, ecosystems, even human well-being.
Okay, this feels like the moment to tackle that core justification head on. Because scientists in this field often get accused of, well, xenophobia, right? A bias against something just because it's foreign. How does the paper handle that?
Yeah, that's a common charge. The paper addresses it by framing it in terms of risk. It argues the scientific stance against non-natives isn't about origin. It's purely about the probability of negative impact. And that probability is statistically just far greater for non-native species compared to native ones. That's the key point, the data point that really underpins the field.
Okay, give us a number. What's the scale of that difference?
Well, if you look at plants in the U.S., for example, the paper cites that the risk of ecologically harmful impacts is something like 40 times higher for non-native plants than for native ones.
40 times. Wow. Okay, that does shift the argument, doesn't it? From, like you said, origin to just cold, hard statistics about risk.
Exactly. It reframes the whole debate.
But 40 times the risk. That doesn't mean every single introduced species is automatically a disaster, which I guess brings us to the next point. The sheer complexity of figuring out what impact even means.
Right. Defining impact is surprisingly tricky. Scientifically, it's defined as any significant ecological change. Doesn't matter if humans think it's good or bad, just change. But of course, different people, different stakeholders, they do assign value based on their own interests, and that leads straight to conflict.
Like that classic example they mentioned, the Japanese tiger prawn. It moved from the Red Sea into the Mediterranean.
Yeah, a great example. For local fishermen, fantastic. A new, valuable catch, an economic plug.
But for conservationists,
a disaster.
Yeah.
Because it apparently led to the disappearance, the extirpation of a native prawn species. So, same species, but viewed as harmful by one group and beneficial by another, diametrically opposed.
And that complexity, it's made even worse by this issue of uncertainty, right? And delays.
Absolutely. Take Europe. They've got over 10,000 non-native populations identified, but only about 11% are currently known to be causing measurable ecological harm.
Only 11%. So that raises the question, if nearly 90% seem okay right now, is the field maybe overreacting? Focusing too much on the worst cases?
That's a fair challenge, and the paper addresses it. The argument is that 11% is almost certainly a significant underestimation. Why? Well, many impacts are subtle. They happen underground or in places hard to study, or crucially, they're delayed. There's a lag.
Right. The invasion debt concept, sort of
Mhm.
lag time. Explain that a bit more.
It means a species can be introduced, sit there quite happily, maybe for decades, even a century or more, not really causing any obvious trouble. And then suddenly, something shifts and it explodes. It starts spreading rapidly.
So we could introduce a plant today, and our great-great-grandchildren, maybe 150 years from now, could be the ones dealing with the ecological fallout. How do you even make policy around that kind of uncertainty?
That's the million-dollar question, isn't it? And yes, that's exactly the problem. Brazilian pepper in Florida is the classic case study. Introduced, stayed pretty contained for about 100 years, then boom, rapid expansion over vast areas.
So today's seemingly harmless introduction could genuinely be tomorrow's ecological nightmare, or maybe the day after tomorrow's.
Precisely. It's a debt that might not come due for a long time.
The paper also talks about a shift in research focus, doesn't it? Moving beyond just the obvious things like predators eating prey to looking at these more pervasive, system-wide effects.
Yes, exactly. Moving from, say, a rat eating a bird egg, which is easy to see, to how invaders subtly transform entire communities and ecosystem functions, often in ways we don't immediately notice.
These are the really insidious ones, the silent invaders changing everything under the surface.
Right. Things happening below ground or affecting nutrient cycles, things most people wouldn't even think about.
Like earthworms. You mentioned North America.
Yeah.
Parts of it didn't have native earthworms after the glaciers retreated.
Correct. And the European earthworms that were introduced, they are profound ecosystem engineers. They're not just little recyclers. They fundamentally change the soil.
How sweet.
They break down the forest floor litter, that organic layer, much faster than the native system was adapted for. This changes nutrient availability, what scientists call mineralization. It can make the soil less able to hold nutrients and water, and paradoxically, it can actually make it easier for other non-native plants to invade.
Wow. So the first invaders basically paved the way for more invaders by changing the soil itself.
Yeah.
That completely flips my understanding of earthworms being universally good.
It does in that context, yeah. And then there's the example of ship rats on islands dominated by seabirds.
Okay, so beyond just eating the birds or eggs, what else?
Think about what seabirds do. They feed in the ocean and bring enormous amounts of marine nutrients back to the land in their guano. It's a massive nutrient subsidy. When rats prey heavily on the seabirds, they effectively cut off that nutrient pipeline from sea to land. The whole island ecosystem, especially the plants and the soil microbes, becomes starved of those marine nutrients. It changes decomposition, nutrient cycling. The whole system suffers because the rats broke that critical link.
That's incredible. These deep, hidden impacts.
Yeah.
It really underscores the challenge, which leads us naturally into, well, what can we actually do about it? Management and mitigation.
Given how complex and delayed these impacts can be, prioritizing action becomes absolutely critical. The Convention on Biological Diversity outlines a clear hierarchy. Priority number one absolutely is prevention. Stop them getting there in the first place.
Makes sense.
If that fails, then it's early detection and rapid response. Find them quickly, act decisively. After that comes eradication, if it's still feasible. And only really as a last resort do you settle for long-term, ongoing management or containment.
And that prevention piece,
Yeah.
it clearly pays off economically too, right? The examples from New Zealand and Australia with their strict biosecurity.
Oh, massively. Their systems, based on rigorous risk assessment, have significantly cut down the rate of new invasions. The paper mentions Australia's plant quarantine program saving something like US $1.67 billion over 50 years.
Wow, that's billions not spent on cleanup later.
Exactly. It's an investment that pays huge dividends. And you see the flip side, the cost of not acting fast in that Caulerpa taxifolia example, the invasive seaweed.
Right, the comparison between California and the Mediterranean is stark.
Absolutely. In California, they spotted it, jumped on it within 6 months, spent about US $7 million, and eradicated it in 2 years. Problem solved. Contained.
And in the Med.
Well, there was delay, procrastination, debate, and in that time it spread over thousands of hectares, multiple coastlines, and now, with the technology we have, it's considered basically ineradicable there.
So that window for rapid response is just
Right.
critical. Waiting doesn't just cost the environment, it ends up costing taxpayers a fortune down the line.
Decades later, potentially. And when eradication is attempted early, the success rates are actually pretty good. The paper looked at over 1,000 attempts, found about an 86% success rate, which is, pretty encouraging.
And it's usually cheaper in the long run.
Almost always. if it's feasible. The Coitu example is telling. 1 year of just managing Koipu populations in Italy was estimated to cost more than twice the entire amount spent on the successful eradication campaign in Great Britain.
So act early, act decisively, save money, save the ecosystem. Seems straightforward.
Economically, yes.
Yeah.
And even when eradication isn't possible for established invaders, the focus shifts to integrated approaches. Active restoration alongside removal, like the Xena forest example in Oregon, using prescribed burns after removing invaders to help restore the native oak savanna.
Okay, so the science seems pretty clear. The economics often back it up. Act fast, act early. Why, then, is it often so difficult to get public buy-in, political will? Which brings us to the societal challenges, the different worldviews.
Yeah, this is where it gets really complex. A big part of it comes down to, well, visibility and charisma. Meaning, the public usually needs to see a problem caused by a visible invader to get concerned. Think kudzu vines smothering a landscape.
Yeah.
That's dramatic, visually arresting, it demands attention.
Okay.
But those earthworms quietly changing soil chemistry, that went totally unnoticed for ages until the scientific research revealed the hidden impact, out of sight, out of mind.
And the charisma factor.
That's about which species we're talking about controlling. Trying to manage or cull, say, feral horses or mute swans, you often get intense public opposition, arguments about animal welfare.
Right. People find them appealing.
Exactly. But campaigns against invasive insects or mollusks usually silence, far less resistance, even if their ecological impact is arguably much greater. It's about how much we identify with or feel affection for the species.
Which then leads back to that whole debate about the language used in the field, doesn't it? The invasion metaphors.
It does. The paper directly acknowledges the criticism that terms like invasion, alien, or military metaphors sound value-laden, even, as you mentioned, xenophobic.
So how does the scientific community respond to that? How do they justify using language that can be perceived as biased?
The core argument, again, circles back to risk and impact. The concern isn't about where a species comes from, its foreignness. It's about the demonstrated higher likelihood of it causing damage. The desire isn't to exclude things just for being different. It's to protect existing native biodiversity and prevent ecosystems worldwide from becoming homogenized, basically simplified and damaged versions of each other. It's invoking the precautionary principle, let's try to prevent really bad outcomes.
And this fundamental clash of values really comes to a head in what the paper calls the ethical triangular affair during management decisions.
Exactly. It describes these three often conflicting worldviews that collide when we try to decide what to do.
Okay, break down the 3 points of the triangle for us.
So first, you have the ecocentrists. Their primary focus is on the health and integrity of the whole ecosystem, the community, biodiversity. They generally favor managing or eradicating invaders to protect the native system. Then you have the anthropocentrists. Their focus is squarely on human interests, economics, health, maybe aesthetics. Decisions are based on what benefits or harms people. And third, the zoocentrists. They place strong moral value on individual animals, their welfare, their right to live. They often oppose lethal control methods like culling on humane grounds, regardless of the species' origin or ecological impact.
Okay, so let's apply that triangle to the feral horse example again. Make it concrete.
Sure. The ecocentrist looks at feral horses overgrazing sensitive habitat and says we need to remove them to protect the native plants and ecosystem.
Right.
The zoocentrist says, hold on, these are sentient animals. Killing them is unethical, regardless of the ecological damage. They focus on the individual horse's welfare. And the anthropocentrist might chime in with, well, do they impact my grazing rights? Do tourists like seeing them? What's the cost of managing them versus leaving them? Their focus is on human utility or cost.
And scientists are caught in the middle.
Pretty much. The paper argues scientists can't settle this fundamental ethical disagreement between these worldviews, but their job is to provide the best possible ecological and economic data, engage respectfully with all viewpoints, and inform the public policy debate, acknowledging that different people hold different legitimate values.
So given all this complexity, the science, the delays, the ethics, what's the big takeaway from this review? What's the path forward for invasion science?
Well, firstly, there's a clear call for better ways to measure and categorize impacts. We need more robust metrics.
Why? Just for scientific understanding?
Not just that, we need quantifiable data on impacts so that economists can do proper cost-benefit analyses. That kind of economic valuation is crucial for making informed policy decisions, for prioritizing which invasions to tackle first with limited resources.
Makes sense. You need the numbers to make the case. And ecologically, Is there a shift in thinking recommended?
Yes, and this is a really important point near the end. There's a need to shift more attention away from focusing solely on the characteristics of the invader itself.
Hmm.
What makes this species successful?
Okay. Shift attention to what?
To how we, through human activities, are changing ecosystems in ways that actually facilitate many of these invasions. Anthropogenic change. We're often inadvertently rolling out the welcome mat.
Ah, I see. So stop focusing only on the bad species and look more at how our land management, water use, transport networks, whatever, how we are creating the conditions for them to thrive.
Precisely. Are our grazing policies favoring invasive grasses? Is the way we manage water flows creating opportunities for aquatic invaders? It's about understanding the ecosystem context that we've altered.
So here's a thought to leave people with, building on that. If we really lean into managing the ecosystem changes that allow invasions, maybe focusing more on things like sustainable grazing or smarter water policies or restoring landscape resilience rather than just reacting to the invader once it arrives, what completely new, maybe more fundamental prevention strategies could we discover?
That's exactly the kind of thinking the field needs more of. Proactive, system-level prevention.
It really highlights that complexity, doesn't it? This deep entanglement of ecology, economics, ethics, making it incredibly difficult sometimes to simply label things as good or bad in our interconnected, rapidly changing world. This has been a fascinating look into a really complex and evolving field. Thanks for walking us through this deep dive.
My pleasure. It's definitely a field that keeps you thinking, and getting a handle on that tension between the ecological data and the very human perceptions and values is, I think, absolutely key to figuring out the way forward.